So the first thing you want to try to do is to write this in a form that we can easily differentiate. Okay, so it's probably best to change the 1 over x to the negative 1. Yeah? So we have 3 minus x to the negative 1 divided by x plus 5. Alright, and just start off and apply the rule as we've just learned. So we let u equal 3 minus x to the negative 1. Find the derivative, du dx is going to be positive x to the negative 2. Okay? And then over here we have v is equal to x plus 5, so dv dx is equal to 1. Alright, therefore, substituting these into our formula, we get y prime is, always start with the denominator, which is x plus 5, so it's v times the derivative of u times x to the negative 2 minus u, which is 3 minus x to the negative 1 times the derivative of v, all divided by x plus 5 all squared. Okay, now we could simplify as much as we can. So x times x to the negative 2 is x to the negative 1 plus 5x to the negative 2. And then over here we have minus 3 plus x to the negative 1. Okay, divided by x plus 5 squared. And then simplifying here, we have x to the negative 1 plus x to the negative 1 is 2x to the negative 1 plus 5x to the negative 2 minus 3 all over x plus 5 squared. Okay, at this point we could actually find, we could simplify and see if there's any common denominators on the top. So for example, the top is really 2 over x plus 5 over x squared minus 3, right, on the top, divided by x plus 5 squared. So we could have a denominator, let's say, of x squared on top, which would give me 2x plus 5 minus 3x squared, and that's all divided by x plus 5 squared. Alright, I'm just not convinced that this form is going to be much simpler than what you're working with already. So we have negative 3x squared plus 2x plus 5, and that's going to be divided by x squared times x plus 5 squared. Alright, so those are the same. Okay, just written in a different form with no negative exponents. That's it. But they're the same. Yes.
Oh, you record?